Okay, this is the end of homework 6 notes from class that I didn't get to finish. So we were talking about functions, and right here they give you 3 functions, f, g, and h of x. So when it says right here, g of 3, you just pick the function that's named g. So we are going to use this function here. Remember, this here is our input. So wherever we see an x, we're going to put 3. We have 6 minus 2 times 3. Order of operations, you're going to multiply before subtract. So you get 6 minus 6, which gives us the square root of 0, which is 0. Right here, I'm going to use f of x. So wherever I see an x, it's f of 0. So that's our input. Wherever I see x, I'm going to put a 0. So I have 3 times 0 minus 1 over 4 times 0 squared plus 1. That gives us 0. This gives us 0. We have negative 1 over 1, which is a negative 1. Now, again, in ALEKS, it may just ask for this. If it asks for an ordered pair or a coordinate, your input was 3 in this case, and your output was 0. Here, your input was 0, and your output was negative 1. Again, we're going to use g, so it's going to be this middle one. You're going to say 6 minus 2 times a negative 6. And on that, you're going to multiply before you subtract, or however you want to say it. I'm just going to say a negative 2 times a negative 6. That gives me a positive 6. Positive 12. So I have 6 plus 12. If you didn't think of it that way, you could think of it this way. 6 minus, and 2 times a negative 6 is negative 12. Double negative becomes positive. So you get the square root of 18. But you can simplify that. You can write that as 9 times 2. Square root of 9 is 3 times the square root of 2. Now notice you're not going to use a positive and negative here because the square root symbol is already given. It's only when you add it in there. Okay, and the last one, h of negative 4. You're going to use this last one wherever you put it. Negative 4 is our x, so you're going to, wherever you see x, you're going to input a negative 4. So you have 3 times the absolute value of negative 4 plus 2. Now again, you can put that in parentheses. It doesn't really matter. Minus 5. Don't forget about that. So we're going to do what's inside here first. Negative 4 plus 2 gives us a negative 2 inside the absolute value mark. Well, inside, this is 3 times the absolute value of negative 2. Well, the absolute value of negative 2 is 2. So you have 3 times 2 minus 5. I'm going to say 6 minus 5 because multiplication comes before subtraction. And we get 1. And again, I think this is what they're asking for, are these two answers. But if it asks for an ordered pair, your input on number 3 was negative 6. Your output was 3 times the square root of 2. Your input on number 4 was a negative 4. Your output was 1. It just depends on what answer it's asking. Here, if it doesn't say round to some decimal place, you're not going to round. Okay, and the last one, for some reason, this is really light. And it's blue. I don't really know. It doesn't look that. It looks better on the screen than it does on my paper, but okay. Right, and I kind of started this on Friday. You're going to find your x and your y intercepts. First of all, this is your x-axis. And I didn't talk about this. And this is your y-axis, because we kind of assume you know this. And let's say you have some graph that looks like this. I don't know, something like that. It doesn't really matter. Okay? You're going to have, in this particular case, you're going to have an x-intercept there and there. you're going to have a y-intercept right here, because it's where it crosses the y-axis. Now, you can only have one y-intercept. You can't have two, because if you have two, let's say it went like this, where you have one here and one here, this isn't a function. It does not pass the vertical line test. So you'll never have two y-intercepts. You'll always just have one. Now on your x-intercepts, sometimes you'll have one. Sometimes you'll have two. You could have 3, 4, 5 of them. You could even have 0 of them. Because if this graph here had been like this, or even something like this, it's not going to cross that x-axis. So you wouldn't have any of them. All right, so to find them given an equation. If you're given a graph, you just look at it, and we'll be learning how to do that on our calculator if it's not a whole number. But anyway, for the x-intercepts, that is where, like this here, that would be some number for my x and 0 for my y. This one here, it would be some positive number, let's say in this particular case, but our y is still 0. So to find our x-intercept, you always set y equal to 0. And I know I did this one on Friday, but it's 2 times x plus 3 times 0 equals 12. That cancels each other. That gives us 0, sorry. 2x plus 0 is 2x equals 12. Divided by 2. And x equals 6. Now, sometimes 6 is fine, but if your instructions say to write it as an ordered pair, then you are going to say my x value is 6 and my y value is 0. In this particular case, it only has one intercept, okay? Because this is a line, so it would look something like this. And that's why it only has one x-intercept right here. Again, it's going to have one y as well. To find our y-intercept, you are going to set your x equal to 0. Nobody saw that. It's in my way. X is equal to 0. Because again, here's your y-intercept. Your x, if you come up on the x-axis, it is 0 some number. Okay? And we're trying to find that number. So we say 2 times 0 plus 3y equals 12. That gives us 0. We have 3y equals 12. Divide by 3. And y equals 4. So again, 4 may be fine, but if it says as an ordered pair, my x is 0, my y is 4. Remember, put the x first, then the y. It's xy. Just like in the alphabet. Right here, to find the x-intercept, again, we are going to set y equals 0. To find the y-intercept, you set x equal to 0. So remember from Friday, f of x is the same thing as y. So we're going to put 0 in for here. X squared minus 4. There are two ways to work this problem. The first way is to factor. This factors as x plus 2, x minus 2. So you set x plus 2 equals 0, and you set x minus 2 equals to 0. So here you would subtract 2, and you get x is equal to negative 2. Here you take 2 to the other side by adding 2. And you get x is equal to 2. Again, if it's an ordered pair, it'd be negative 2, 0, and it'd be 2, 0. The other way we could have written this, or we could have worked this problem, is take that 4 to the other side, and we get 4 equals x squared. That error is bothering me. Now, I don't want to know what x squared is, I want to know what x is. So I'm going to take the square root of both sides. And because I put that square root symbol in there, it is a positive and negative 2. Just like we ended up with over here. Okay, so that's the x-intercept. So notice we have 2 in this case. That's because it's a parabola. Right here, you're going to set x equal to 0. So if you want, you can put f of x, if you want to, equals 0 squared minus 4. Or you can do this and put y equals 0 squared minus 4. Either way, it's the same thing. This gives us 0, so 0 minus 4 gives me negative 4. So again, depending on how they want the answers, if they want them just your intercepts of negative 2 and 2, or if they want an ordered pair, you'd put this. Again, I'm just not sure. So on your x-intercept, your y-intercept, it'd be negative 4. Again, if it's an ordered pair, it'd look like this. Okay, here, when you are working with absolute values, you've got to isolate them. You've got to get them by themselves, okay? So, or actually in this case, never mind, we're not solving for them yet. Let's see how this goes. X-intercept, again, you're going to set y equals 0. So I'm going to put 0 here equals 3 minus the absolute value of x. Okay, I was telling you correctly. When solving problems like this, you've got to isolate this square, absolute value mark. So it's negative here. I'm just going to take that whole thing to the other side by adding the absolute value of x. Okay, that way it just looks better to me. All right, now you've got two numbers that x can be. All right, it can be equal to 3, or you take that x and you set it equal to negative 3, and those are your answers. So again, 3 and negative 3 is probably what they want, but an ordered pair would be 3, 0 and negative 3, 0. Now the reason you have both of these is because, remember, absolute value is the distance from 0. Well, here's 0. You've got a number over here to the right 3 units away. Well, that would put you at a positive 3. Well, you also have a number 3 units to the left. That's a really bad brace, which is at a negative 3. That's why when you're solving absolute value symbols, you set it to the positive and negative. But in order to do that, you have to isolate or get the absolute value by itself. Okay, to find the y-intercept, you're going to set x equal to 0. So you're going to take, again, you can put g of x equals 3 minus the absolute value of 0, because that's what we're plugging in for x. But if you want to, you can interchange that with y, because it's the same thing. And you get 3 minus 0, which is y equals 3. Again, depending on how they ask, it would be 0 for my x, 3 for my y if it's a coordinate. Okay? All right, right here, same as before, our x-intercept. We are going to set y equals 0. It would help if I will move this up for you to see. So I'm going to plug 0 in here, equals x plus 2 over 3x minus 1. Well, what I don't like is I don't want to work with fractions, so I find my least common denominator and multiply it. The least common denominator is 3x minus 1. What I do to one side, I have to do to the other. Okay, well, this is really over 1. These two cancel, so on the right side, I'm left with x plus 2. Over here, when I say this times 0, it still gives me 0. So I'm going to take that minus 2 to the other side by subtracting it. So I get negative 2 equals x. Now for my y-intercept, I'm going to set my x equal to 0. And I'm going to plug it in right here. 0 plus 2 over 3 times 0 minus 1. So 0 plus 2 gives me 2. 3 times 0 is 0. 0 minus 1 gives me negative 1. So I get negative 2 as my answer. And that's it.